So elimination, same thing, 6 steps. Multiply equations by a constant. We want the coefficients of a variable to be opposite. So what that means is, if the coefficient of y is 9, we would like the coefficient of y in the second equation to be negative 9. Okay, we want them to be opposites of each other so they can cancel out. Okay, so step 1 here is multiply equations by a constant. So now you might be asking yourself, what makes it okay for us to multiply equations by a constant? Well, this is what. Okay, 3 plus 5 equals 8. True equation? Absolutely. If we multiply this whole thing by 2 and distributed the 2 to everything, 2 times 3 would be 6, 2 times 5 would be 10, 2 times 8 would be 16, 6 plus 10 is 16, still true. So multiplying the entire equation by a constant is a legitimate thing, it's something we can do. Okay? We want the coefficients of the variable to be opposite. So our x coefficient is negative 4. We can multiply the bottom equation by 4 and have our x coefficients be opposite. Our coefficient to y in the top equation is 9. We can multiply the bottom equation by 3 so that the coefficient of y in the second equation is negative 9 and they'd be opposite. Either way is fine. I'm going to go ahead and choose to cancel out the y's. So I'm going to multiply that bottom equation by 3. So that's going to be 3x minus 9y equals 18. Okay? And now that's your new system. Alright? So we multiply by a constant so that we can cancel out some variables. So now we're going to add the system of equations. Okay? And you guys might be asking yourself again, what in the world, can we just add 2 different equations? Well, let's check it out. 2 plus 3 equals 5. I don't know, 5 plus 4 equals 9. If we add those equations, 5 plus 2 is 7, 3 plus 4 is 7, 5 plus 9 is 14. That's still true, so we can in fact add equations to each other and have it be a valid math process. Okay? So here, we're going to add these equations together. Negative 4x plus 3x is going to be negative x. 9y plus a negative 9y, they're going to cancel out. 9y minus 9y is going to be 0y's. And that's what we want. That's what we're looking for. We're looking to cancel out some of the variables, one of the variables, so that we can solve for the other. Okay, so now 9 plus 18, that should be a negative 18, because we multiplied that whole second equation by 3. So 3 times negative 6 would be negative 18. So 9 plus a negative 18 is going to be negative 9. So if negative x is negative 9, positive x is going to be 9. Divide both sides by negative. Alright, so now we have one of our variables. Okay, solve for a variable, that's what we just did. Now step 2. Step 4, plug into the original equation. Alright, so come back up here, plug it into one of the equations that we started with. I'll pick that top one. So, in equation 1, negative 4 times 9 plus 9y equals 9. Now we're going to go through, we're going to solve for y. So negative 4 times 9 is negative 36 plus 9y equals 9. Add 36 to both sides. 9y is going to equal 45. Divide by 9 on both sides. And y is going to equal 5. So step 6, we forgot a step. Step 6 should be write your answer as an ordered pair. Okay? So ordered pair, the x value of our answer is 9, y value is 5. So our answer is ordered pair, it's still a point on a graph. Alright, so now step 6 or step 7 is going to be check your answer. Alright, so check my answer with the first equation. Negative 4 times 9 plus 9 times 5 should equal 9, so that's going to be negative 36. plus 45 equals 9. That's a true thing. Negative 36 plus 45 does equal 9. So equation 2 here. Equation 2. For equation 2, you could either substitute it in for the original equation or the equation after you multiply by a constant. We saw that it's not going to change its value. It's still going to be a true thing when we multiply by a constant. So either way is okay there. I like to substitute it in for the original equation. So x was 9 minus 3 times 5 equals negative 6. So that's going to be 9 minus 15 equals negative 6. That's a true thing. 9 minus 15 is negative 6. So our solution to this system works. Our solution of 9, 5 works for both of the equations.